Welcome to Math with Mr. J.
In this video, I'm going to cover the distributive property and how we can use the distributive property to simplify algebraic expressions. We will start with an introduction. After that, we will take a look at more examples, and then lastly, we will look at some algebraic expressions that we will need to simplify using the distributive property and combining like terms. Now, the distributive property can help us remove parentheses within algebraic expressions. This helps us simplify expressions when we do not have like terms within parentheses that we can combine. Now remember, when we have something next to parentheses, that means multiplication. So we can use the distributive property to distribute whatever is on the outside of the parentheses to the terms inside the parentheses. The distributive property works when we have addition or subtraction inside of the parentheses. So at the top of the screen, there is a general overview of the distributive property where A is being distributed to the terms inside of the parentheses. The distributive property and that overview will make a lot more sense as we go through our examples. Let's jump into number 1, where we have 2 and then in parentheses 5 plus 3. And we're going to do this two different ways, by using the order of operations, so doing what's in the parentheses first, and then also using the distributive property. Now for number 1, we don't have any variables involved. We are actually able to add what's in the parentheses first and then go from there. We don't have to use the distributive property. But the point of number 1 is to show us that we get the same thing either way. This is going to show us that the distributive property doesn't change the value of an expression. We are able to use this strategy. So again, we get the same thing either way. Let's start by using the order of operations and doing what's in the parentheses first. We have 5 plus 3, which is 8. Bring down the 2. And now we have 2 times 8, which is 16. Now let's use the distributive property and see if we still get 16. So we need to take that 2 on the outside of the parentheses and distribute it to the 5 and to the 3. So we have 2 times 5 plus 2 times 3. 2 times 5 gives us 10, plus 2 times 3 gives us 6. 10 plus 6 is 16. So we get 16 that way as well. So we can see that the distributive property doesn't change the value of an expression, and we are able to use it. Let's move on to number 2, where we will apply this to an algebraic expression in order to simplify the expression. We are going to remove the parentheses. For number 2, we have 8, and then in parentheses, 2m plus 6. Now we can't combine those terms in the parentheses. So what we can do, we can use the distributive property to remove those parentheses and simplify this expression. So let's distribute the 8 to the 2m and to the 6. This gives us 8 times 2m plus 8 times 6. 8 times 2m is 16m plus 8 times 6 is 48. Now 16m and 48 are unlike terms, so we don't have any terms that we can combine. So we are done here. 16m plus 48 is our simplified expression. Let's move on to number 3, where we have 7, and then in parentheses, a minus 9. Let's distribute that 7 to the a and to the 9. That gives us 7 times a minus, bring the subtraction sign down, 7 times 9. 7 times a is just 7a, minus 7 times 9 is 63. So we end up with 7a minus 63. We don't have any like terms that we can combine. So we are simplified and done. Again, 7a minus 63. Now I do want to mention another way to think through this, and this is another way to think through whenever subtraction or negatives are involved. So let me rewrite the expression and then distribute the 7. So we have 7 times a, which is 7a, and then we can think of that subtraction sign and the 9 as a negative 9. So including the sign in front with the 9. So we think of that as a negative 9. So let's distribute that 7 to the negative 9. 7 times negative 9 is negative 63. So negative 63. And we get 7a minus 63 that way as well. And again, that's just a different way to think through it. You get the same thing either way, but you can include the sign in front of the term and think of that as a negative 9. So something to keep in mind. Let's move on to number 4, where we have 10 and then in parentheses, negative 5x minus 4y. Let's distribute the 10 to the negative 5x and to the 4y. So 10 times negative 5x minus 10 times 4y. 10 times negative 5x gives us negative 50x minus 10 times 4y gives us 40y. So we end up with negative 50x minus 40y. We don't have any like terms that we can combine, so we are done. Again, negative 50x minus 40y. Now let's take a look at a different way to think through this. So I will rewrite the expression off to the side. So let's distribute the 10 to the negative 5x, and then we will think of that as negative 4y. So include the sign in front of that term. 10 times negative 5x is negative 50x. And then 10 times negative 4y is negative 40y. So we get the same thing that way as well. Negative 50x minus 40y. So there is an introduction to the distributive property. Let's take a look at 4 more examples. Here are more examples that we can go through to get the distributive property down. Let's jump into number 1, where we have 9 and then 3c plus 2 in the parentheses. Let's distribute that 9 to the 3c and to the 2. So we have 9 times 3c, which is 27c, plus, so we bring that addition sign down, and then we have 9 times 2, which is 18. So we end up with 27c plus 18. Now we don't have any like terms that we can combine, so this has been simplified. We can't simplify any further. So again, 27c plus 18. Let's move on to number 2, where we have 4 and then in parentheses, negative 6y minus 5. Let's distribute that 4 to the negative 6y and to the 5. So 4 times negative 6y is negative 24y. Bring the subtraction sign down, and then we have 4 times 5, which is 20. So we end up with negative 24y minus 20. We don't have any like terms that we can combine, so this is simplified. Again, negative 24y minus 20. Now, I do want to mention another way to think through number 2, and this is an option when we have subtraction. So let me rewrite the expression here. And then we need to distribute the 4. So distribute to the negative 6y. And then when we distribute to the 5, we are going to look at this as negative 5. So we are including that subtraction sign, the sign in front of the 5, and look at this as negative 5. This gives us, well, 4 times negative 6y is negative 24y. And then 4 times negative 5 is negative 20. So we get negative 24y minus 20 that way as well. So we get the same thing either way, just slightly different as far as working through the distributive property. Let's move on to number 3, where we have negative 2 and then in parentheses, negative 8x minus 7y. Let's distribute the negative 2 to the negative 8x and to 7y. So negative 2 times negative 8x gives us 16x. Remember, a negative times a negative is a positive. So negative 2 times negative 8 is a positive 16, and then we have that x. Then we can bring down the subtraction sign, and then we have negative 2 times 7y. That gives us negative 14y. Now this is correct, but we can clean this up a little bit, so to speak. We have a double sign, the subtraction and then the negative. We don't need both of those signs. We can rewrite it with just one. Think about working with negatives. When we subtract a negative, that's the same as adding a positive. We can change this to addition, and that will make this simpler and, like I said, clean it up a little bit. We can rewrite this as 16x plus 14y. We don't have any like terms that we can combine, so we are simplified again, 16x plus 14y. Just like number 2, I'll go through this a slightly different way as far as thinking through the distributive property when it comes to subtraction. I will rewrite the expression off to the side here. And then we can distribute that negative 2 to the negative 8x. And then we can distribute that negative 2 to the negative 7y. So we are including that sign in front of the term. Negative 2 times negative 8x gives us 16x. And then negative 2 times negative 7y gives us a positive 14y. So plus 14y. So we get the same thing there as well. Lastly, let's move on to number 4, where we have 15 and then 3g plus h in the parentheses. So let's distribute that 15 to the 3g and to the h. So we have 15 times 3g. That gives us 45g. Plus, and then 15 times h, well, that's just 15h. So we end up with 45g plus 15h. We don't have any like terms that we can combine, so we can't simplify this any further. This is simplified. So again, 45g plus 15h. So there are the basics of using the distributive property to simplify algebraic expressions. Let's move on to some examples of algebraic expressions that will need to be simplified using both the distributive property and combining like terms. Here are 4 more algebraic expressions that we need to simplify. We will use both the distributive property and combining like terms. Let's jump into number 1, where we have 4 plus 2, and then in parentheses, n plus 6. Now, since this expression has parentheses, we need to start there. Do not do 4 plus 2 first. We still need to consider the order of operations. Within the parentheses, we have n plus 6. N and 6 are unlike terms, so we can't combine those terms. What we can do is use the distributive property to remove the parentheses, and then we can look to combine like terms to simplify the expression further. So let's distribute the 2 to the n and to the 6. 2 times n gives us 2n. And then we have 2 times 6, which gives us a positive 12, so plus 12. This is a positive 2n, and then we can bring down that 4. Now that the parentheses have been removed, we can look to simplify further by combining like terms. 4 and 12 are like terms. Those are constant terms, so we can combine them. 4 plus 12 gives us 16, so our final simplified expression is 2n plus 16. Now, when we write expressions, typically speaking, we want any variable terms first and then constant terms go last. So that's why we have 2n plus 16. If we end up having multiple terms that involve variables, they go in order from greatest to least as far as exponents. And then if variable terms have the same exponents, go in ABC order. So again, for number 1, we just have two terms, a variable term and then a constant term. So 2n plus 16 is our final simplified expression. Now that final simplified expression is equivalent to the original expression. We were just able to simplify that original expression by using the distributive property and combining like terms. Let's move on to number 2, where we have 6, and then in parentheses, 3x plus 5, and parentheses, minus 9x. Let's start by using the distributive property to remove the parentheses. So let's distribute this 6 to the 3x and to the 5. 6 times 3x gives us 18x, and then 6 times 5 gives us a positive 30, so plus 30. Then we have minus 9x, so a negative 9x. Now that we removed the parentheses, we can look to combine like terms. 18x and negative 9x are like terms, so we can combine them. Make sure to include the sign that's in front of a term. That's negative 9x. So we have 18x minus 9x, or 18x combined with negative 9x. That gives us a positive 9x. And then we have plus 30, a positive 30. So our final simplified expression is 9x plus 30. Let's move on to number 3, where we have 23 plus 3, and then in parentheses, 8y minus 10. Let's remove the parentheses by using the distributive property. So let's distribute the 3 to the 8y and to the negative 10. 3 times 8y gives us 24y, and then 3 times negative 10 gives us negative 30. This is a positive 24y, and then bring down the 23. Now, as far as the distributive property and subtraction, we can also think through that as 3 distributed to 8y, so 3 times 8y, that gives us 24y. Then we can bring the subtraction sign down, and then distribute the 3 to the 10. So 3 times 10, that gives us 30. So 24y minus 30. We got the same thing thinking through the distributive property that way as well. Now that we removed the parentheses, we can look to combine like terms. We have two constant terms, 23 and negative 30. So we can combine those like terms. So we have 24y, and then 23 minus 30, or 23 combined with negative 30, gives us negative 7, so minus 7. Our final simplified expression, 24y minus 7. Lastly, let's move on to number 4, where we have negative 8, and then in parentheses, negative c minus d, end parentheses, minus 5d. Let's start by removing the parentheses by using the distributive property. Distribute the negative 8 to the negative c, and distribute the negative 8 to negative d. Negative 8 times negative c gives us a positive 8c. Remember, a negative times a negative equals a positive. Negative 8 times negative d gives us a positive 8d. And then we have minus 5d, so a negative 5d. Now that we removed the parentheses, we can look to combine like terms. 8d and negative 5d are like terms, so let's combine those like terms. We end up with 8c, and then 8d minus 5d, or 8d combined with negative 5d, gives us a positive 3d, so plus 3d. Our final simplified expression, 8c plus 3d. So there's how to use the distributive property and combining like terms to simplify an algebraic expression. Let's take a look at 4 more examples, and these will get a little more complex. Here are 4 more algebraic expressions that we need to simplify using the distributive property and combining like terms. These will get a little more complex than the previous 4 examples. Let's jump into number 1, where we have 13a plus 4, and then in parentheses a plus 9. Now, since we have parentheses, we need to start there. We can't combine the terms in the parentheses, they are unlike terms, so we can use the distributive property to remove the parentheses. Once the parentheses are removed, we can look to combine like terms. So let's distribute that 4 to the a and to the 9. So we have 4 times a, which is 4a, and then 4 times 9 is a positive 36, so plus 36. This is a positive 4a, and then we can bring down 13a. Now that we removed the parentheses, we can look to combine like terms in order to simplify this further. So do we have any like terms that we can combine? Yes, 13a and 4a are like terms, so we can combine those terms. 13a plus 4a is 17a, and then we have that positive 36, so plus 36, and this is our final simplified expression, 17a plus 36. Now that simplified expression is equivalent to the original expression. We were just able to simplify that original expression by using the distributive property and combining like terms. Let's move on to number 2, where we have 5, and then in parentheses x squared minus 3, end parentheses, plus 10 minus 4x. Let's start by using the distributive property in order to remove the parentheses. Then we can look to combine like terms. Let's distribute this 5 to the x squared and to the negative 3. 5 times x squared gives us 5x squared, and then 5 times negative 3 gives us negative 15. Now, another way to think through that distributive property there is to do 5 times x squared, which is 5x squared, bring the subtraction sign down, and then do 5 times 3. We get 5x squared minus 15 that way as well. Just a slightly different way to think through the distributive property. Then we have a positive 10, so plus 10, and then a negative 4x, so minus 4x. Now that we removed the parentheses, we can look to combine like terms. So do we have any like terms that we can combine? Yes, we have 2 constant terms, negative 15 and 10. So let's combine those like terms. So we have 5x squared minus 4x. That's a negative 4x. The term will take the sign that's in front of it. So make sure we have negative 4x there. And then the constant term comes last. So we have negative 15 plus 10, or negative 15 combined with positive 10. That gives us negative 5, so minus 5. And this is our final simplified expression, 5x squared minus 4x minus 5. Now I do want to mention, as far as how this simplified expression is written, typically speaking, when writing expressions, the greatest exponent comes first, so greatest to least. If exponents are the same, go in ABC order. constant terms go last. So we have 5x squared. The exponent of 2 comes first because that's the greatest exponent. Then we have negative 4x, so that variable has an understood exponent of 1. Remember, whenever there isn't an exponent written, there is an understood exponent of 1, so to the power of 1. Anything to the power of 1 is just itself. And then we have the constant term of negative 5 last. So that's something to keep in mind as far as writing out expressions. Let's move on to number 3, where we have 7, and then in parentheses, g plus 3h, and parentheses, plus 4, and then in parentheses, 2g minus 6h. Let's start by using the distributive property to remove any parentheses, and then we can look to combine like terms. Let's distribute this 7 to the g and to the 3h. So we have 7 times g. That gives us 7g. And then we have 7 times 3h. That gives us a positive 21h. So plus 21h. Then we can distribute the 4 to the 2g and to the negative 6h. 4 times 2g gives us a positive 8g. So plus 8g. And then 4 times negative 6h gives us negative 24h. A positive times a negative equals a negative. So negative 24h or minus 24h. Now for this expression, I'm going to rewrite it with all of the like terms next to each other. This is a strategy we can use to organize the expression and make combining like terms a little simpler, since all of the like terms will be right next to each other. So let's identify any like terms in this expression. We have 7g and 8g, and then 21h, which I will box in order to separate, and then negative 24h. Let's rewrite this with those like terms next to each other. So we have 7g plus 8g plus 21h minus 24h. Remember, that's a negative 24h. Now all of the like terms are right next to each other. So like I mentioned, it's a little simpler to combine the like terms. So now we can combine like terms. Let's start with 7g and 8g. 7g plus 8g gives us 15g. Then we have 21h minus 24h. So positive 21h combined with negative 24h. That gives us negative 3h. So minus 3h. And this is our final simplified expression, 15g minus 3h. Lastly, let's move on to number 4, where we have 18x minus 10, and then in parentheses, 2x minus 2y plus 9, and parentheses, minus 6x. Let's start by using the distributive property to remove the parentheses. We're going to distribute negative 10. We take the sign that's in front, so this is negative 10. We need to distribute to the 2x, to the negative 2y, and to the 9. Negative 10 times 2x gives us negative 20x. Negative 10 times negative 2y gives us positive 20y. Remember, a negative times a negative equals a positive. And then we have negative 10 times a positive 9. That gives us negative 90. We then have the negative 6x and the positive 18x that we need to bring down. Now we can look for any like terms that we can combine. So do we have any like terms? Yes. 18x, negative 20x, and negative 6x. Let's rewrite the expression with those like terms next to each other. So 18x minus 20x minus 6x plus 20y minus 90. Now we can combine like terms. So we have 18x minus 20x minus 6x. So we are combining a positive 18x, a negative 20x, and a negative 6x. 18x minus 20x is negative 2x. Negative 2x minus 6x, that gives us negative 8x. Then we have plus 20y minus 90. So negative 8x plus 20y minus 90 is our final simplified expression. So there you have it. There's all about the distributive property and how we can use it to simplify algebraic expressions. I hope that helped. Thanks so much for watching. Until next time, peace.